you'll probably have your drawings there as a reference later on. And then just I'm going to take some notes on that. Should be it for us.
Bless you.
Hey.
Bless you.
All right, so we'll start off talking with about our conduit schedules. So when I say a schedule, I don't necessarily mean a timeline, like at 8 o'clock we're gonna run this piece of conduit. No, this is more of just a general map, so you know kind of where things are going and kind of what size they are. It's just kind of some general information. Like I said, it's kind of somewhat of a roadmap. It's just you don't know the exact path. You just know the beginning and the end. So for our conduits, so all of our circuits, so every single circuit, receptacles, lights, and our power circuits shall be encased in conduit. So every single circuit we run, or have ran, technically, in here, is going to be encased in conduit. Now we're going to do something a little bit different. So this is kind of one of those situations where we're going to kind of step away from the real world for just a second. So typically in the real world, if you had a panel up here, say maybe this is our receptacle panel, you are going to have some larger conduits that are leaving, and then that larger conduit is going to kind of hit a generalized area. Then you're going to have a junction box, and then it will kind of spider out and go to individual circuits from there. Typically that's how it's done. But for our project, rather than having that scenario, we're going to say from our panel, leaving from the panel, we're going to have all of our circuits in their own individual conduits. Is that realistic? No, probably not, because the panel's not going to be able to handle that many circuits. But again, that's one of the benefits we have for our project, is we can kind of make up some stuff like that. But it makes it'll make things easier on you guys. So I'm going to add an exception to this bullet point up here. And this is just to kind of help you out. So we haven't talked about our main feeders just yet. We're actually going to talk about that next week. But the only exception, the only kind of circuit that's not going to be encased in conduit is our main feeders. So like I said, I know we haven't talked about our main feeders yet, but I'm just letting you know that. So that way next week you're not like, oh, do I need to come back later and fill in some conduits? No. Main feeders are not going to be encased in conduit. Okay, so in your design notebook, if you go pretty much all the way to the back, or second to last thing, sorry, is our conduit schedule. So if you go to the very back of the book, you'll see a conduit schedules cover page. And then of course, the sheet after that is the conduit schedule. So I'm going to kind of walk you through on how this table is laid out, what all these columns mean, and kind of do a little running example with you. So we kind of have three sections. We have the conduit section, the conductor section, and I'll just call this little section over here kind of miscellaneous because it has a couple of different things in it. But starting over here on the far left, we have our conduit number. So typically you're going to have your wire that's labeled something. For example, receptacle circuit 12. The conduit that it is encased in also has a name, right? Now typically that conduit and the circuit number are two totally different things. And not only that, but you also have, typically in the real world, a lot of other circuits inside of that conduit. So they usually don't always match up. So what I would recommend doing is if you have receptacle circuit 12, for example, I would just call the conduit number CRC 12, conduit for receptacle circuit 12. So what that means, that's our conduit, that's what would be written on the side of it. So typically you write your conduit name on the side of it, so that way if you're ever having to trace it and follow it and go through multiple rooms or anywhere, you kind of know where that conduit's going. And then of course, receptacle circuit 12 would be the wires sitting inside of it. So for your conduit number, I would just add a C into whatever circuit you're talking about, not just receptacles, but lights and power circuits. I would just add a C in front of it, so that way it has a different naming convention. And that way you know it's the conduit and not the wires. I'm going to kind of fill that in for an example here. Okay. Next column we have is our conduit size. So this is the size of the conduit that we're going to say is required for those wires. That's actually going to be the last thing that we talk about in here because we need just a little bit more information before we can determine that. So we'll skip that for now, but come back to it. The next column, length. All right. Well, you don't have to go remeasure anything because you already have all those distances. So for example, this receptacle circuit 12, if that's in our office, you would come back over here to your receptacle office wire sizing. You'd come over here, find receptacle circuit 12, and you'd say, all right, for example, if that was 100 foot of wire, then you're going to need at least 100 foot of conduit, right? So you already have all the distances for everything. So whether it's a receptacle in the office, receptacle in the shop, lighting circuit in the office, or lighting circuit in the shop, and your power circuit wire sizes, you already have all those distances right there. So you don't have to remeasure anything. So according to your circuit that you're working on, you're just going to go back to the corresponding wire size page and get its length. So like I said, I'm just going to say, for example, that that was maybe 100 foot.
And this is for the office receptacles or for the shop receptacles?
It's going to be for everything.
So what about the ones that share like circuit numbers? If it's like,
Huh?
you've got like receptacle circuit 1 in the shop, receptacle circuit 1 in the...
So that's where I encourage that continuation of the numbering system from the office to the shop in there. If you did the same numbering system, it's not the end of the world. I'm not going to make you go back and renumber all that stuff. I would just make a separate page for it because you're going to have multiple of these pages anyways. So I would just have a separate page on there. Okay. So that was kind of our conduit section. Moving over here to our conductor section. That first column says number / AWG. So what that translates to is quantity / wire size. So number, meaning the number of wires that are going to be in there, and then / and then AWG. AWG is talking about your wire size. So kind of going back to your code class, but if you were to wire up this receptacle down here, how many wires would you need? 3. So what are those 3 wires?
Ground, hot, neutral.
Ground, hot, and neutral. Very good. So receptacle circuits are always going to have 3 wires. What about your lights? How many wires are you going to need for them? 2? What would those 2 be?
Be like 4, right? 'Cause you need control.
So what would you said 2, so what would 2 wires be?
Hot, neutral.
What happens if you have a ground fault?
I guess ground cable.
Alright, so we need 3 wires, right? Hot, neutral, and ground, because all of our lights are single phase. So I know y'all haven't wired up too many lights out here, or maybe none at all, with a ground, like in motor controls or drives or anything else that you're wiring stuff up in. Typically don't have a ground on the lights, but normally you're gonna have a ground on your lights. So that would be 3 wires. And then our power circuits, remember those are feeding our machines mounted on our motors, but how many wires are gonna be on there?
It's 3 phase, right?
Mm-hmm.
Okay. 4?
So what are those 4 wires?
Your 2 hot,
Phase and ground.
your neutral, and your ground.
So think back to your machines class. On a 3-phase motor, did you ever wire up a neutral? No.
Took 3, you got 3 ons and a ground.
There you go. So you're gonna have A, B, and C phases, and then you're gonna have a case ground. So for our power circuits, they will be quantities of 4. So, again, you're gonna go back to the corresponding wire size page, whether it's in the office or shop for receptacles or lights, or your power circuit page. And you're gonna say, all right, well, for these receptacle circuit 12, let's just say I have, of course, we're gonna have 3 wires, but let's just say it was a number 12 conductor that you sized. Well, it would look like that. For your lighting circuit, maybe you had, well, of course, you're still gonna have 3 wires, but maybe you size a number 10 on that circuit. And then for your power circuit, let's just say you had a machine, of course you got 4 wires, maybe you came out to a number 8 in size. But that is kind of how your finished example will look. So 3 and 4 being your quantities of wire, and then of course your wire size that you selected, going back and looking at those wire sizing pages. So if you look at the next column, it says the same thing, number / AWG, but the difference between the two is one says power, the other says control. So kind of going back to motor controls just a little bit. There's my little example of kind of what y'all were looking at. But y'all remember looking at your ladder diagrams that looked like this? So this top portion of our circuit up here, what did we call this portion of it? What? Oh wait, what'd you say?
Control? No.
No, not this portion. Just the portion up top here with our motor.
Power?
Power circuit, right? So this portion up here was our power circuit. In motor controls, this was the 208 feeding your motor. And then what did we call this portion down here?
Motor control.
There you go. This was the controls portion. So kind of where they get the term motor controls, right? So typically this is where you're having your push buttons and timers and all that stuff to control the motor up here. So for our project at least, have we done anything with controls?
No.
No. But have we done stuff with power? Yes, absolutely, right? All these wires, of course I didn't draw them on there, but the overloads and the main starter and everything like that, or main contacts for the starter, we've done all of that. So we haven't really touched controls. And just FYI, we're not going to touch controls in here. Well, technically we will a little bit, but we're really not gonna do anything with the controls. So, on this control column, everything here is not applicable. It's in A. Simply just because we're not doing anything involved with the control portion of what the circuit would be in our project. We just don't have the time for it. Alright. Then our next column says voltage. But for a receptacle circuit, whether it's in the shop or the office, what voltage is going to be present? 120 volts. Okay. For our office lights, what voltage is present on them? What? 120, right? What about our shop lights? So remember the shop lighting panel, that plugged directly into the MCC bus.
Is it 240? Or
Close, divide that by square root of 3.
208.
There you go, 277 for our shop lights. And then our power circuits feeding our machines. What voltage is on there?
480?
480. There you go. So, depending on what circuit you're working on and where, your voltage is going to change on here. So, depending on, like I said, what that circuit is, you're going to fill that in here. So, on this example, I got this receptacle there in the office. All receptacles are 120 volts, so that's what I'll fill in on this example here. And if you notice, again, the following column, it says voltage again. Again, we have the power and control side of it there. Again, we're not doing the controls. So, for the control column, we'll fill in NA. Now, the last column inside of the conductor portion of it is our insulation. And what type of insulation is our conductor that we're using on all of our circuits, no matter what?
THHN.
THHN, there you go. So that will kind of be a constant as well, because like I said, that's not going to change. All right, then we have our miscellaneous column here. So, the very big box, it says conduit type, EMT. So that is the type of conduit that we're going to use for every single one of our circuits. EMT stands for electrical metallic tubing. So that will not change. Below that, we have a from, to, and for column. This is kind of that roadmap that I was referring to. So we don't know exactly the path that it takes to get there, but we know the beginning and the end. So the from column, this is the beginning. So like I said, think of it if you're going to take a road trip, you're going to start your destination from your house or your apartment, right? So if I'm looking at this receptacle circuit 12 example here, and that's in the office, that circuit starts or originates from the office receptacle panel, right? That's where that wire starts. When it plugs into the, or we tie it into the breaker and we plug that into the panel, that's where that circuit starts. So this is where all of your circuits start. And that's subject to change. Office receptacles are fed out of the office receptacle panel. Same thing with the office lights. They're fed out of the office lighting panel. But you get to your power circuits, they're not fed out of a panel. They're fed out of the MCC. So you would have to list whatever MCC they're in. But it's just anywhere those circuits originate from. The to column, that's the destination. Where are you going to? I'm leaving from my house and I'm driving to Florida or wherever, right? So in this example, this conduit is going to go from the ORP and it's going to simply just the receptacle circuit 12 on your drawing. So you could look at your drawing, the office receptacle drawing, for example, and you can say, all right, there's my office receptacle panel and there's receptacle circuit 12. So again, we don't know exactly the path that the conduit will take, right? There's a lot of different roads you can get to one place, but we at least know where it starts and where it's going to. And then the last column there, the for, that kind of comes back over here to our power and control conversation. Is this going to our power circuit or is this going to our control circuit? Again, we're not dealing with anything on controls, so everything's going to be listed for power purposes, even if it's a receptacle or a lighting circuit. And that will kind of be a constant too, so I'm going to drag that down just to show that. Okay, so that was the majority of our table here. The last thing that we have is that conduit size. So this is where our code books are going to come in handy. So let's start out and turn to page 715. That will bring you to the beginning of chapter 9. For me, it's on page 715. Might be a different page number for you, but that's the page number I got. Oh, is yours a little bit different? At least it was pretty close. We're just looking at the very beginning of chapter 9. We're actually going to start off looking at table 1. So, if you recall from your code class, sizing conduit is not necessarily an easy feat, right? There's a lot of things that go into it. Like, for example, looking here at the beginning of chapter 9, you have table 1. That is talking about your fill percentage. So depending on how many conductors you're going to stuff inside a conduit determines how much of that conduit you can fill up. So then you have to kind of take that information, and if you flip the page, then that brings you to table 4, where this is giving you all the cross-sectional area and that different conduits and different sizes of conduits have. And then if you flip the page a couple of more times, you're going to come across table 5, where it's giving you the area of the conductor and its size and its installation. And then you have to do all this math and subtraction and make sure that it's actually within that fill percentage. And there's a lot of work that goes into it, right? But you have to do all of this when you have different sized conductors inside of a conduit. So when we're talking about sizing our wires here inside of our conduit, technically we could have one wire size for the hot, a different wire size for the neutral, and an even different wire size for the ground for the code book. But for the simplicity of our project, we're just gonna say, well, if we size this receptacle circuit at a number 12, that's gonna be a number 12 hot, a number 12 neutral, and a number 12 ground, right? So they're all gonna be the same size, which is really gonna help us out, especially when it comes to sizing this conduit. So we don't have to do any of this math for it, or thankfully. The code book's gonna do all that math for us. So we're gonna skip a few pages. To, just a second while I find it. Page 773. Page 773, we're looking for the very beginning of informative annex C. So Annex C is talking about conduit, tubing, and cable tray fill tables for conductors and fixture wires of the same size. So just like what we have, if we're putting all the same size wires in a conduit, the code book has this section dedicated for that scenario, doing all the math for you. So if we look at our index here, the very first table there, it says C.1, EMT, electrical metallic tubing. That's exactly what we're using. However, if you also notice right below that, C.1A with an asterisk also says EMT. So which table do we need to look at? Well, if we go down to the bottom of the index, that little asterisk is telling us, says, hey, where this table is used in conjunction with tables C1 through C13, the conductors installed must be of the compact type. So what they're talking about is, we're not using compact wire, by the way, but you got your regular old, let's just say, stranded wire. So that's what we're using, and that's what y'all are used to using around here. But your regular old stranded wire, you can't really tell most of the time, but whenever you kind of cut your wire, there is a little bit of an air gap in between each one of those strands. So what they do is they'll take that same piece of wire, but then they'll run it through a press. Typically that press is going to turn that shape into a hexagonal kind of shape. Not Picasso, but you get the idea. And so whenever they push it through that press, well, now all of your strands aren't circular, they're kind of squared, like so. And now that air gap between all those little strands has been eliminated. So that wire is smaller. This is not to scale, by the way. But typically that wire is smaller because they pressed what little bit of space we had in between those strands out. Okay? Now that's great for some situations, but again, we're not using compact stranded wire. So whenever we look at these tables, we need to ensure that we're using table C.1. Not C1A. So that makes it pretty easy for us. So all we have to do is just flip the page once, and then we're at table C.1. So looking at this table here, C.1, there's really three kind of columns of information. Starting on the far left, we have our type. That's referring to our insulation type. The second column being our conductor size. And then the third column, it has a whole bunch of sub-columns, but it just says trade size. That's just a fancy way of saying conduit size. And if you notice all those sub-columns, those are conduit sizes there. So we'll do a couple of examples here, but the very first thing we need to do is figure out where our insulation type is. So if you kind of go down that column of type, we're looking again for that THHN. And as you kind of scroll through there, you should find THHN, and it is coupled with THWN and THWN-2. So we are only looking at that one portion where it says THHN. That's the only portion of this table that we're looking at, because that's our installation for our conductors. So doing this little receptacle circuit example here, where we got number 12 wire, whenever we go to our second column, we're gonna look at conductor number 12, and then we're gonna slide across horizontally, and we're gonna look at our trade sizes. So the very first one, 3/8, what does it tell you for number 12?
Nothing.
Nothing, it's blank, right? If we kind of zoom out for just a second, all the 3/8 stuff is blank. They don't make a 3/8 EMT conduit, so we're gonna be hard pressed to find anything on that. That's okay, so we'll go over to the next size, 1/2 inch. What value do you see?
9.
Should be 9 for a number 12 conductor. So what is that 9 referring to? What does that tell you?
The number of conductors that can fit inside that size.
Very good. So that number 9 is telling you can fit 9 number 12 THHN conductors inside of a 1/2 inch EMT conduit. That's what that's telling you, maximum, without crossing over that 40% fill. So the code book is doing all the math for you. So kind of looking at this little example here of, like I said, this little receptacle circuit, could we use that 1/2 inch conduit?
I mean, it's like that's like the lowest one though.
Yeah, we're only putting 3 wires in there, but the code book's telling us we could fit up to 9. So we can use that all day long, right? Absolutely. So in this little example here, this one would be a 1/2 inch conduit. Alright, let's do this little power circuit example up here that I wrote down. So let's say we got 4 number 8 conductors. So if we look there, number 8, of course we're not using 3/8, but for 1/2 inch, what value do you see? 3. Can we use that conduit? No, because we're trying to fit 4 wires in there, but the code book already did the math and said, hey, you can only fit 3 in there. So, no big deal. If that happens, you just slide over to the next conduit size, which is 3/4, and what value do you see there?
6.
Now can we use that conduit?
Yes.
Yes, absolutely, in that example. So, this little power circuit example would be 3/4 inch. So like I said, if you encounter that, where you can't use that 1/2 inch, because that will happen sometimes, that's okay, you just slide over to the 3/4, and you just keep sliding over until you find the size that does work. Okay. So does everybody understand how table C1 is working? How to utilize it? Okay. Does everybody understand the conduit schedule itself? This table up here.
This is gonna be for everything, like receptacles, lighting, and the power,
Yep.
so everything we put in so far.
Everything, yes.
Alright.
Do you want like 3 separate sheets?
So, as far as the sheets being made, I would break it up a little bit. I wouldn't just put it all on one sheet. You don't have to break it up too terribly much, but I would probably do one for the office receptacles, the shop receptacles, office lights, shop lights, and then you could probably put all your power circuits on one. So I'd probably make like 5 sheets, and you can do that same little, where you like click on the tab and then make the copy box like what we did a couple weeks ago with the lighting calculations. You can do that same thing for this page and just copy it, but I would probably make about 5 sheets to kind of break up this flow. And not only that, but it helps you make sure that, you know, your voltages, or maybe even like the quantity of wires, you're making sure that you're getting those correct and not just kind of copying and pasting that whole thing all the way down. Yeah.
Would you want us to, when we make those copies, go in there and, leave it as 1, 2, 3, or would you want us to put like power, lighting, RC, whatever? Or
Are you talking about, renaming the tabs down here?
Yeah.
You can, either or is fine.
Okay.
Yeah, either or is fine. I'll be able to know kind of what it is exactly, kind of looking at the from and tos. So, and of course the circuit numbers and stuff. So yeah, either or is acceptable. What other questions y'all got?
How do you, when you copy it, we're supposed to put, before page?
Yeah, so for the before page, you would need to pick the panel schedule cover page in this example, because you want it before that page.
I just moved.
Everybody's good with the conduit schedules? Okay, so, we're gonna kind of switch gears a little bit now. So, we talked about conduits, now we're gonna talk about our panels. Okay, so before we dive off into the panel schedules, I've typically found it over the years to be a little bit helpful to kind of go over some, what I call breaker panel anatomy, kind of how it's structured, how it's working. This seems to help you guys out a little bit. So you're gonna get a little slideshow lecture from me here. But, does everybody recognize this panel up here? Where have y'all seen this before?
Code class.
Code. That's exactly where I took this picture from. So, now this might not be or this is not, I should say, this is not the exact panels we're using in our projects, but if you know one 3-phase panel, you kind of know them all, right? It's just, there's not much differences between them. So I'm picking equipment that is familiar with y'all. So this did come from our code lab. So I'm gonna zoom in here just a little bit on the bus bar system. We're gonna talk about a couple of things. First one being our phase sequencing. So y'all have heard that term before, right? From your advanced AC class, hopefully, maybe even in your EPD class. So that's just the order or the rotation of our phases. So it's beneficial to us because this panel inside of there, it has that constant same rotation of ABC, 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 ABC. It doesn't change. It's not going to be all of a sudden CBA or anything. It's always ABC. So whenever we start plugging breakers in there, it kind of helps load balance itself a little bit, considering if all your circuits are about the same wattage, it kind of load balances it between all three of those phases. So again, kind of going back to your advanced AC, that's helpful. And it also helps us as technicians to prevent swapping any two leads, at least in the panel. So once we kind of get our breaker wired up and it's plugged in, that's kind of fixed. We're not, unless we change the wires on the breaker, it's not really swapping any two leads. But how is it able to do all of that? Is if we kind of look here behind the insulation, because a lot of this is covered in this insulation, but behind this black plastic insulation, this is about where your A-phase bus bar sits at. And if we look here, oh, never mind, just kidding. But about right here in the middle, this is where your B-phase bus bar sits. It's kind of right here in the middle. And then always, for the most part, your C-phase is mirroring your A-phase. So it kind of sits about right here. So if we just look at A-phase and just isolate it, we'll notice that these tabs here, that they start their tab on the left-hand side and they extend towards the right-hand side, but they don't make connection with anything else. So if we look at the very top, it starts with A, it skips 2, and then it's A-phase again. If we look at B-phase, those are easy to identify because since that bus bar is in the middle, the little bus system kind of curls up. The reason it does that is so that way you can have a connection to a breaker on both sides of that little curl there. So if we notice here, it now starts in the second position but then it still skips 2 and it's B phase every other 2. And then C phase, again, kind of mirroring that A phase, but now if we look at these little tabs, it starts its connection on the right-hand side and goes towards the left. So it starts in the 3rd slot and it skips 2 and it's C phase again. Keeps that skip, skip, skip all the way down. So when we kind of put all that together, that's where we get that phase sequencing or that phase rotation of ABC, ABC, ABC. All right, so the picture over here on the left, you have your big breaker up top, which is fixated with that little metal bracket. We technically could move that over to the other side or somewhere else, but it's fixed in our code lab. But then down here at the bottom, this little single pole breaker, this is probably what you brought your wire into to run over to your receptacles or lights or whatever y'all were doing for that day. But if you notice, both of these breakers are on the left-hand side here. So all I did was I took this picture and then I grabbed this breaker, pulled it out, and I came over here and punched it in on the right-hand side. So this is just to show you that in that panel, those tabs that we just looked at, they are made to handle those breakers on both the left and the right-hand side. So some places like Canada only utilize 1/2 of the panel. We're not Canada. We pay for the full panel. We're going to use the full panel, right? We're going to use both sides of it. So this is just to show you that you can have breakers on the left and the right-hand side of this bus system here. And again, even if you open up your panel in your apartment or your home, you're going to see breakers on both the left and the right-hand side. Now, I don't know what happened to the panel covers from the code lab. I guess we threw them away, so I didn't have a panel cover of those. So I just walked literally right across the hall and took a snapshot out of this panel, which is in motor controls. So now y'all don't have too much experience with this panel because this was where the instructor would be at whenever y'all were like, hey, I'm ready on station, whatever. Also, with that being said, kind of ignore those Sharpie marks on there. That's just us scribbling on there. So, like for example, if you're like, hey, I'm ready on station 10, then we would know to turn on this breaker. That's all that means. But for our project, kind of ignore the Sharpie marks. But anyways, there's a lot of good information on here. And it might be a little hard to see in this picture, but one of the things is called circuit numbers. And they are physically stamped in numbers on the side of the panel from the manufacturer. And they're just like house numbers. You have all your odds on the left-hand side and all your evens on the right-hand side. So, I think I got a little bit closer picture here. Yeah, so not the Sharpie marks, but can y'all see those stamped in numbers on there? If y'all are having trouble seeing that, that panel I have back here also has them in there. Any newer panel is gonna have those physically pressed in numbers on the side of them. Some older panels, probably not gonna have it, but any newer modern panel is gonna have those circuit numbers pressed in there. And that's important because if we kind of remember what we looked at before we put this panel cover on, if we look there, that very first one, circuit 1, well, that's referring to that A-phase extension that we looked at. So that breaker right there plugs into that extension. Likewise, circuit 3 plugs into that left-hand side of that B-phase extension. Circuit 5 corresponds to C-phase, and so on. Same thing on the other side. Circuit 2, it's tied onto that same A-phase extension that circuit 1's tied into, right? Because that breaker is tapping into that connection on both sides. So the other side, circuit 4, tied into the same B-phase connection as circuit 3. Same thing with circuit 6. It's the same C-phase connection as circuit 5, and so on. So, that was the physical numbers pressed in the panel. Those are called circuit numbers. Now, on the inside of the door, there is the actual panel schedule. So typically when people say a panel schedule, that is what they're referring to. When you open up the door, it's that piece of paper glued on the inside of it there. It has all kinds of information on there. If there's any kind of torque rating specifications, that's where you're gonna have your amp rating information, just a whole bunch of good information, that we're not gonna really deep dive off into that, but what we're more interested in is kind of that table down there. So, this is a zoomed up picture of that table, but you kind of notice here on this table, they have all of your odd and even circuit numbers. So again, what those numbers are physically stamped into on the side of the panel. And if we look here at circuits 1, 3, and 5, that we'll look at that first one, it says trainer number 1 in that circuit 1 slot, and then it has a line across 1, 3, and 5. So that's just shorthand for saying that, hey, that breaker and that circuit are occupying those 3 spaces. That's all that means. So rather than writing trainer number 1, trainer number 1, trainer number 1, they just wrote it one time and then drew a line across it. That's all that means. So that would tell you, just looking at that, that would be a 3-phase breaker in this 3-phase panel. So, of course, in here it's just listed as trainer numbers, but if you open up the panel in your home, this is where it's going to say master bathroom, garage, kitchen, you know, whatever else, living room, you know, this is where you're going to have all your different naming conventions in here. So, something else useful with this, maybe not so much in this panel because they're all bigger 3-phase breakers, but like in the panel in your house, say you need to replace the receptacle in your kitchen, right? Well, when you open up your panel to go turn off the circuit, rather than kind of looking at this sheet and going, all right, well, it says kitchen's around here, let me just kind of guess. No, they put those numbers on the sides there to match those stamp numbers, so that way you can say, oh, well, my kitchen receptacles are on circuit 16 here, right, or circuit number 16. So then you can find that physically stamped in number on the panel and you can turn off that specific breaker. So it's just kind of help you kind of guide to where that is rather than guessing. Okay. All right, so did that kind of help provide a little bit more information maybe you knew or maybe didn't know with everything? Okay. So, with that knowledge kind of in our mind now, this is a screenshot of your panel schedule cover or panel schedule page, excuse me, in your notebook. So, this is the very last item in there. So, if you want to kind of click over a few pages in your notebook, you will see this exact same page. So, how do we fill this out? Well, starting up at the very top, we have our panel number. So, this is where you're going to have ORP or OLP or shop receptacle panel. Whatever panel you're working on listed here. So I'm going to kind of go over all the panels that you're going to have. So we're going to have our office receptacle panel, our office lighting panel. I'm going to assume that everybody in here has 6 MCCs in their shop. So if you have 6 MCCs, you're going to have shop receptacle panels 1 through 6. So a total of 6 shop receptacle panels. We're also going to have our shop lighting panel. And then there's one other panel that we cannot do at this moment in time, and that's called our main distribution panel, or MDP. But we cannot do that panel at this moment in time. This MDP, that's going to house the breakers for our main feeders. But that's housing the breakers for our main feeders. But we haven't talked about main feeders yet. We're talking about that next week. But before we can talk about main feeders, we have to do these panel schedules for these other panels before we can get to there. So, if we count up here, you got 1, 2, assuming there's 6, that would be 8, 9, and then this 10th one here. So you should have in total 10 panel schedules. But again, we cannot complete this main distribution panel right now. But I would still go ahead and make a page for it at the moment. title it MVP, and then just leave it blank. So that way you kind of have a reminder after next week to go back in and fill in that panel schedule. But we should have in total 10 panel schedules. Okay. Kind of going across the top there, location. This is where those panels are located at. Don't just say office or shop. Be specific with it. So for your office panels, the ORP and OLP, don't just say office, say mechanical room, because that's the room that they're located in. If you're talking about your shop receptacle panels or your shop lighting panel, put what MCC it's in there. Don't just say shop. So, for example, if you're working on shop receptacle panel 3, that's in MCC 3. So make sure you put that. So, but be specific with it. Over here we have our voltage, phase, and amp mains. So we'll go over the voltage and phase later, but as far as your amp main information, for the ORP and the OLP, those we're going to say are 400 amp mains. And again, that's kind of a somewhat made up number because we said that there was no circuit limitation to those two panels in our office. So we're just going to say that they're 400 amp panels. They may or may not actually need to be those size panels, but again, we don't have specific data on that. But our shop receptacles and our shop lighting panels, those are specifically 100 amp panels. Like I said, we'll go over the voltage and phases towards the end.
So are we actually using those?
What?
Those 400 amp, 100 amp?
And the last little bit there up at the top where it says surface mount and flush mount, it's talking about breaker construction. That has no bearing whatsoever on our project, so don't even worry about filling that out. So that's kind of the general information up top. Now coming down here to this table portion of it, this is kind of the meat and potatoes of it. So this table starts in the middle and then works its way out on both sides. This is mirroring the breaker panel and everything that we just kind of looked at. It's kind of looking at all that anatomy and it's kind of putting it all on one page. So starting in the middle, we have our phase sequencing. So thankfully, now all of our panels are 3-phase, so they should always have that phase sequence of ABC, ABC, ABC. So that should not change. Again, working out on both sides. The next set of columns we have is our circuit numbers. So again, those are those physically stamped in numbers from the manufacturer. So a couple of things with that. I gave you a hint down here saying that 16 is for the max for your shop receptacle panels and technically the shop lighting panel. So again, kind of going a few weeks back to when we started talking about shop receptacles, but remember how I told you only 16 arrows can point back to each MCC, and what was it, last week we put in that shop receptacle panel on the one-line drawing? Well, that panel can only hold 16 circuits. So these two are capped specifically at 16. Again, the office receptacle and lighting panels, they do not have a size limitation. But your shop receptacles and shop lights, they are capped at 16. And something else, I even made a note of it over here as well, but one of the common mistakes I see on panel schedules is if you do shop receptacle panel 1, for example, and you go 1 through 16, and then you go to shop receptacle panel 2, what number do you start with again for your stamp numbers?
1.
It should be 1. Very good. So, common mistake is I'll see people put 17 right there. No, it's not 17, right? Because if you kind of think about it, say if you bought that panel from Home Depot, let's just say for example, you come home, you install the panel, you put everything in it, and you're like, man, I need another panel. So you go back to Home Depot. Well, do you think when you pull another one off the shelf, it's going to start with 17? for a circuit number stamped on there? No, because this manufacturer's manufacturing them in bulk, so they're just stamping 1 through 16 on all of them, right? So every single panel schedule you do needs to restart at circuit number 1, right? So your ORP and OLP can go from 1 to however many circuits you got, because that's what we're saying, there's no size limitation. But your shop receptacles and your shop lighting, those start at 1 and are capped at 16 circuits. Can't put any more than 16. But that number resets every schedule.
For the office, since we don't have a cap, we just copy this ABC down
Yep.
until we run out of.
Yep, so like I said, if you got 50 circuits in the office, for example, then you're just gonna kind of copy everything down until you fill in everything for the office.
Same with the conduit as well.
Do what?
Same with the conduit side as well, like we copy and paste down. Like if we have more
I
than
think you're
what's.
saying on the table, you can expand.
Oh, like,
Yeah.
yeah.
Yeah, okay.
I'm sorry, I was like lost, I was not trying to hear, but yeah. All right, our next set of columns is our breaker trip. So this is the size of the breaker. Now, for our receptacles and lights, have we sized any breakers or overcurrent protection for those things?
Yeah.
Did? I must have slept that week. So we have not sized any breakers for those receptacles or lights, and we're not going to, okay? So, if you look at my little note down there, I say for most circuits it will be 20 amps. Where I get that, I'm not gonna make y'all look at it, but in the code, Article 240.4D, as in Delta, it's talking about small conductors and their corresponding overcurrent protection. And it basically says if it's not a motor circuit, i.e. receptacles or lights, excuse me, then depending on what your wire size is gonna determine the breaker size. So very similar, hopefully I'll talk about it in code, but like if you had some yellow Romex, that's 12-2 Romex, should have a 20 amp breaker tied to it. Very similar, if you got some white Romex, that's 14-2, then that should be tied to a 15 amp breaker, right? So since our minimum wire size for receptacles and lights, and really anything in our project, but for receptacles and lights, is number 12. If you look at that code reference, number 12, copper conductor, it says a 20 amp breaker. So that's where I got that information. So we will fill in 20 amps for almost all of our circuits. The only one that we're not gonna fill 20 amps in is a piece of equipment inside of our office receptacle panel. Anybody wanna take a guess on what that is? Our AC unit. So our AC unit will be the only one that is not 20 amps. Let's do this. Does anybody happen to remember what the breaker size is for that air conditioner? I'll give you a hint. It's 80 amps.
That only takes up one spot.
No, that is a 3-phase breaker, so. Make note of that up here too. And I'll typically go over and kind of show how to install that, but that is a 3-phase breaker. That's a good point you bring up there. So it has to make connection with A, B, and C phase. Now, talking about that, does it have to be in that order? Does it have to be A, B, C for your air conditioner? It does? Listen. I mean, think about it. If you're just plugging breakers in, does it have to start at A phase at the top of the breaker, or can it start at B phase, or can it start at C phase? As long as you got 3 phases hooked up to it, right? And you got your wires labeled appropriately, and you're bringing A phase to A phase, B phase to B phase, and C phase to C phase, it should run no problem, right? So your AC breaker does not have to start on A phase. It can start on B phase, or it can start on C phase, or wherever it lands on your panel. It does not have to start on A phase. like I said, I'll kind of go over that example here in a little bit.
The AC unit,
Do what?
you're going over the AC unit and how it's supposed to show on the.
Yeah, I will here in a little
That's in
bit.
your receptacle panel?
Huh?
That's in your receptacle panel?
Yes. All right, next set of columns, our number of outlets. So outlets, I know is a slang term for receptacles, but per the code, outlet's definition in layman's term, anything that's drawing current. So that could be a receptacle or that could be a light. So I know up until this point, for a lot of everything that we've done, I've just been saying, well, just use 4 receptacles on a circuit, or a full circuit of receptacles, or a full circuit of lights for all of our wire sizing and things like that for future expansion. And that's fine. But here, this is where we're gonna be specific, okay? So you're gonna pull up your drawing. For example, if this was receptacles in the office, you're gonna pull up your receptacle drawing in the office, you're gonna look and you're gonna say, okay, well, circuit 1 has 4 receptacles on there, I'm gonna put that. Or if it only has 3, then you're gonna put that. Or if it has 2 or 1, you're gonna put how many receptacle or how many devices are actually on that circuit. Same thing with your lights. If you got 10 lights on a circuit, great. If you only got 4 lights or 1 light, then put those respective numbers on here. And that kind of ties into the next set of columns, which is our load. Yeah.
Do you wanna mirror that info on both sides? Cause I know there's like 2 different sides of the.
Right, this is your left and your right hand side. So they're not necessarily mirrored, they are in the terms of their information, but what you're filling in there is gonna be 2 separate sides, right? We're just utilizing both sides of the panel. So you're gonna have this breaker here for receptacle circuit 12, for example. But then this one over here might be receptacle circuit 14. Well, it might not have the same number of receptacles or lights or whatever on there. But it's the same information, it's just you're filling in for those specific.
You just wanna treat it like it's like its own separate page, basically. Like if you just stacked it on top of each other. And you were
Kind
to
of.
keep on going down.
Odds
Yeah.
on
It's
left,
mirroring it right.
evens on right.
That's that piece of paper on the panel.
Yeah, pretty much. We're just adding some more information on top of that. Yeah, pretty much, yeah. But like I said, the number of outlets, how many devices you have on each circuit tie into your load columns here. So again, this is where we're being specific. If you have 4 receptacles on a circuit, then you're gonna put 1600 watts. If you had 12 receptacles, or excuse me, 3 receptacles, then you're gonna put 1200 watts, right? Now, one thing to be cautious of is since we're also doing our shop receptacles, you could only have 2 receptacles on a circuit and still have 1600 watts, right? For your machine mounted receptacles. So, or 1 receptacle and just have 800 watts. So kind of keep that in mind. For your lighting and its loads, if you don't remember what those are off the top of your head, go back to those wire sizing pages. The notes over there on the left-hand side, they tell you how much wattage each one of those devices are worth. And then lastly, we have our circuit ID columns, not circuit numbers, but circuit ID columns. So this is where we're gonna be filling in receptacle circuit 12, lighting circuit, whatever. So this part, odds and evens do not matter. You don't have to put odd numbered circuits over here, even numbered circuits over here. You don't have to follow that. That's only for your circuit numbers. So this is again, kind of where you would see like kitchen or master bathroom or whatever in your panel in your apartment or your house. So this is just whatever we wanted to name it. So instead of calling receptacle circuit 12 that, we could have called it executive office receptacle circuit 1 or whatever, right? It just depends on whatever we wanted to name it. We just decided to just use RC and a number, right, for simplicity. So odds and evens don't matter on this, but you are gonna fill in kind of what circuit you're working on. Okay. So does everybody understand how this is filled out?
Can you talk about that last piece again?
Which piece?
How it's circuit different from the circuit number?
Yeah, so this is just our circuit ID, so whatever we're calling our circuits. So like I said, we could have elected to say, you know, executive office receptacle circuit 1, right? Or, you know, break room, executive break room receptacle circuit 1, and, you know, men's restroom receptacle circuit, like, we could have called all of our receptacles that, but that would just be a lot more work. We just decided to name them RC1, RC2. But the circuit numbers here, those are those physically stamped in numbers from the manufacturer. So that is where you're gonna have odds and evens.
Okay.
Because that's not changing. But the circuit IDs, that's just whatever we call our circuits, which is, like I said, just RC or LC, they're numbered.
I have a question around the, so on the load side of things, if you go to your receptacle, right, will it have the information that will say, if you had, I know you're not gonna have one receptacle per circuit, but will it have the info of how much watts that is?
Yep, so if you go over there, it'll tell you how many watts are per device. That's for receptacles in the office, the shop, the lighting in the office and the shop. It tells you the wattage for each of those devices. So if you only have one, it'll say, that's kind of how it's listed, it'll say each device is however many watts. So if you had 3 or 2 or however many on there, then you just multiply it by that wattage.
You can find that in your notes or find that in the bulletin book or something like that?
No, it's in your notebook. If you go back to like the office wire receptacle, or the office receptacle wire sizing page, for example, those notes over there off to the left, it says all of that on there. Same thing in the receptacles in the shop, lights in the office, and lights in the shop. They all have that information listed.
Appreciate it. Could you explain the breaker?
That's just the size of the breaker.
Oh, okay.
Yeah, so for all of those circuits, for all of our receptacles and lights, because we didn't size those breakers, we're just gonna say they're 20 amps.
Okay.
The only one that's not going to be 20 amps is our AC unit. That's the only exception. Everything else will be 20 amps. Yep.
I see that it says that this will change depending on what panel you're in. Can you explain that?
So your amp mains, that information changes, and then here in just a second, we're gonna talk about all the voltages.
How do you find the load for your AC unit?
We did that last week, right?
In the bulletin book.
No, we did that calculation together. Whenever we did our office transformer sizing, that's step 3, right? Okay. All right, so pop quiz time. But your office receptacle and your office lighting panels have what voltage present in them, and how many phases?
120.
That's half of it. Multiply that by square root of 3. No. You can use your calculator if you need to.
480 coming in, right? To the panels.
No, that's coming into the office transformer, but we sent out what voltages to the,
208 or 207?
there you go, 208, 120, and those are 3-phase. What about all of your shop receptacle panels?
280.
Huh?
280.
What?
280?
No, not 280. 208, that's half of it. What's the other half? 120, right? So we're using receptacles. They have 120 volts on them. It's just a 3-phase panel. And what about your shop lighting panel? What voltage does it have? So remember, that's the one that plugs directly into the MCC bus.
480.
There you go, 480, 277. Of course, that one's also 3-phase. Okay. I know we talked about conduit schedules too this morning, but this is like apples and oranges. These are 2 different things. So, if you noticed, when we talked about our conduit schedules, I mentioned power circuits. As we've been having our conversation about panel schedules here, have I mentioned anything about power circuits? No. Okay, so you do not have panel schedules for your power circuits. It is just for receptacles and lights. And eventually our main feeders. But it's just receptacles and lights for us right now. Reason for that is because our power circuits that feed our machines are not fed out of panels. They're fed out of the MCCs. So their quote-unquote panel schedule is the elevation drawing, right? So there is no panel schedule for the power circuits. If it's not out of a panel, then it's not a panel schedule. I said the power circuits are fed out of those MCCs, so you do not have to worry about the power circuits on this. And then I already kind of told y'all about that main distribution or main feeder panel, this MDP panel. Again, I strongly recommend that you go ahead and make a blank page for this MDP, label it the MDP, and then that's it, because you don't have the rest of the information to fill it out. But at least you have that blank page created, so that way when you're flipping through your project, if you forget to do that after next week, you don't miss it, right? So at least you have a blank page kind of as a reminder to go back and fill that in. Okay, so just to kind of give you all a little example here of some stuff. Yeah. So for example, let's just say I'm going to do the office receptacle panel here. So I'm going to title that the ORP location. That's the mechanical room. Our voltage and phase information, we just went over that, so that's 208, 123 phase, and that's a 400 amp main panel. So whenever you go to fill in this panel schedule, this is just like if you're plugging breakers in to the panel. So typically you start on the left and then you go to the right, and go back to the left, back to the right, back to the left, right? You kind of hop across. You don't just fill in one side of it and then come back in and fill the other side. You typically kind of hopscotch both sides there. So for example, like if I was going to put in RC1, I would label that. I would look on my drawing and I would say, okay, well this one has 4 receptacles on that, and that would come out to 1600 watts. Of course, the breaker trip's always going to be 20. Again, those circuit numbers, those are the physically stamped in numbers. So these will always be the odds on this side. So we could kind of label that all the way down. Same thing on this other side, this will always be our evens. So that would be my first breaker that I plugged in. So then I'm going to kind of hopscotch over here to the next side. And let's say this is receptacle circuit 2. Let's say this one only had 2 receptacles on it. Well, that's only going to be 800 watts there in my office. Of course, that's still a 20 amp breaker. Now, let's just say this next circuit, RC3, when I come back over here on the left-hand side, let's say that's my AC unit, okay? So you could fill in here, you could go RC3, RC3, RC3. You could do that. There's nothing wrong with that. Or kind of the equivalent of putting that line across for the trainer that we looked at on the example for motor controls, you can just simply merge that together and just say, all right, well, that's RC3. The load, I think one of y'all was asking about the load for the AC unit. Well, what was the load that we calculated for the AC unit last week when we sized that office transformer? Very good. It was 28.82 kilowatts. Number of outlets, well, we only have 1 air conditioner. And the breaker trip, that's that 80 amps. So you can merge all of that information, kind of like what I did here, but you cannot merge those stamped circuit numbers, right? Just like what we looked at, circuit 3 corresponds to B phase, circuit 5 corresponds to C phase. So, and like I said, it's okay if your AC unit breaker doesn't start on A phase. If it starts here on B phase or even C phase, that's fine. If it starts on A phase, that's great too. But in this example here, as I was going across, that's fine. So whenever you do your AC unit, wherever it may lie, in your numbering there. But as I come across over here, I would fill in like RC, C4, I would do also RC5, and I would fill in RC6. And then once I kind of gotten even, so to speak, with this AC unit, then I'll jump back across and then go back to like my little hopscotch method there. So y'all see how that's kind of working?
That's for the AC unit like that, correct?
Yep, yeah, this is just
Why
like
would you
AC.
put RC3 for your circuit name? Why would you, why don't you just put AC unit or like?
So if I look at your drawing on there, that little tag, is it gonna say AC unit? No, it's gonna say RC whatever, right? So if you wanna make a note and say in parentheses maybe, like, hey, this is the AC unit, if you wanna do something like that, that's fine. But it has to match that drawing, right? So if you pull up that drawing, that tag, that's tied to that AC unit, that's what's listed on there, not AC.
And when we do our machine mounted receptacles, they're gonna be three-phase, so it's gonna be like 3 columns, right? And
Well, so the machine mounted receptacles are just the receptacles, right?
Yeah.
The machines themselves are the power circuits.
Gotcha.
So yes, your shop receptacle panel will be a 3-phase panel, but nothing's really changing as far as what you're doing here. Of course, the AC, this is the only breaker that we'll put in like this. Everything else will just kind of be this single row, single phase. The only thing that's different is, like I said, you might have only 2 receptacles on a machine mounted circuit and it'd still be 1600. That's the only difference there.
But the outer wall receptacles are the same as the office
Yep.
receptacles.
Yep, where you got 4 of them at 1600 watts. Yep.
So only your machine mounted ones would be where 2 adds up to 1600, right?
So like I said, go back over here in your book. So all these wire sizing pages, all these notes over here, they're telling you, hey, each receptacle is this many watts, right? Outer wall receptacles, this many watts. Machine mounted receptacles, this many watts. Same thing with your lights. All of that information is things that we've already kind of went over, and you also have that already available to you. Okay, now one thing I did want to also make note of is, I'm just going to scroll down here to the bottom rather than making a brand new page, but it's our lights in the shop. So if you recall from a couple of weeks ago, when we did that, we came up with 3 lighting circuits in the shop. Y'all remember talking about that? So the only time you're not going to kind of like hopscotch across both sides of the panel is on your shop lights, because we only have 3 circuits. So for example, I'm gonna scroll down just a little bit. Let's just say, like I said, I'm not gonna kind of redo all this per se, but let's just say this was my shop lighting panel.
Yeah, what would be the point of hopscotch?
Exactly. So if we kind of, like I said, this is just kind of my little mock-up here, but if we did lighting circuit, I don't know, I'm just gonna say 31 in the shop, right? And I came over here and then I did lighting circuit 32, and then came back over here and did lighting circuit 33. Well, that's all 3 of my circuits in the shop. Well, now if I look at this, this isn't balanced, and that defeats the whole purpose of why we broke up our shop lights into specifically 3 circuits. It was so it could be balanced. But now, if you do that little hopscotch method, you now have 2 circuits on A phase and only 1 circuit on B phase, and absolutely nothing on C phase. Because that shop lighting panel is still a 3-phase panel. So your shop lights, it's the only exception, but that's when you're gonna come in here and you're gonna just do lighting circuit, for example, 31, 32, and then you'll list 33. That way you have 1 circuit on A phase, another circuit on B phase, and another circuit on C phase. So they're all evenly balanced on there. That is for your shop lights only. Everything else, you'll kind of do that little hopscotch method. Okay. So is everybody good with the panel schedules?
So we need to have 4 different sheets for this one.
You'll have in total 10 sheets.
Oh, 10 with the MCC.
Yep. Yeah, so you'll have a total of 10, assuming you have 6 MCCs. That's the assumption I'm making. If one of y'all has happened to do 5 MCCs, it says it's not technically wrong, just makes things a little bit more difficult. But if you have 5 MCCs, then technically you would only have 9 total pages. But I'm assuming everybody has 6, so it should be a total of 10 pages. And you can do that same like copy.
Copy that.
Yeah. Okay. So everybody's good with the panel schedules? Alright, couple of things here before I let y'all go. Alright, so that was week 8 material. So like I said last week, I don't think this is a difficult week by any means. A lot of this information we're talking about today, you already have it. You just have to kind of almost copy and paste it into these other sheets. So it's not really difficult and really generating any more work. You're just, like I said, kind of number crunching on the keyboard there. Next week, which is physically week, or realistically week 10, but we're going to be covering week 9 material. That is our main feeder calculations. Just letting you know, that's going to be a busy week. Next week's going to be a while. Okay, so make sure you bring everything, your code book, all your drawings. I highly encourage you get completely caught up with this week and everything else that we've talked about up at this point. But make sure you are ready to go for next week. So we're going to dive off back into some complex code calculations. There's going to be a lot of calculations involved next week. So make sure you bring your coffee or Red Bull or whatever you need to for next week. Also, so that's as far as our class goes. But as far as employment events and everything else going on,